adding and subtracting rational expressions. So we're still working with these fractions with variables in the denominator. Okay, but now we want to add or subtract two of them together, okay, instead of multiplying or dividing. So just as with rational numbers in fraction form, to add or subtract two rational expressions that have unlike denominators, you must first find the least common denominator. Okay, the LCD is the least common multiple of the denominators. Okay, so you have to find that least common multiple. You have to get a common denominator. Okay, so you want to get a common denominator in order to add or subtract these fractions together. So to find the LCM of two or more numbers or polynomials, you have to factor them. Okay, so we're still factoring. The LCM contains each factor the greatest number of times it appears as a factor. Okay, so with our numbers, if you have 5 over 6 plus 4 over 9, you have a 6 and 9 in the denominator. You need to have a common denominator in order to add them. Okay, so your least common multiple of 6 and 9, you would factor 6. 6 is 2 times 3, and 9 is 3 times 3. So their least common multiple, I have to for sure have this 2 and 3 in there. If I move to 9, I already had a 3, so I need just one more. Okay, so I have 2 times 3, or 18. Okay, that would be your least common multiple. With polynomials, you would have to factor this and factor this. Okay, so if I factor x squared minus 3x plus 2, that would be x minus 1 times x minus 2. And if I were to factor 2x squared minus 2, first you take out a 2. Okay, once I take out a 2, I have x squared minus 1, which factors into x minus 1, x plus 1. Now to find that least common multiple, I always just rewrite what that first term was. So you for sure need this x minus 1 times x minus 2. Now when I go to this next one, I already had an x minus 1, so I don't have to write it again. Okay, but I didn't have an x plus 1, so I will have to write that one out. And I didn't have a 2, so I'll have to write that one out. Okay, so that would be your least common multiple there. And you can just leave it like that. You don't have to FOIL it out afterwards. Okay, leave it in factored form. So in example 1, I do want to find the LCM of each set of polynomials. Okay, so it's just kind of like what they were doing up here. Okay, but we're given 3 terms. Okay, so our first term here is 12a squared b. So I'm going to write 12a squared b. And I'm going to write the factors of that. So 12 can be split into 3 times 4, right? So if I have 3, what is 4? How do you factor 4? 2 times 2. So 12 can be broken down into 3 times 2 times 2, where that 2 times 2 is 4. And then I'm just going to rewrite this a squared and b. Okay, so you don't have to write a times a. You can if you want to, but you can just leave it as a squared. My next term here is 15abc. Okay, factoring 15. 15 can be broken down into 3 times 5. And then I still have A, B, and C. Last one is 8b cubed c to the 4th. Okay, 8 can be broken down into 2 times 4, right?
Yeah.
And 4 would be 2 times 2. So we have 2 times 2 times 2. And then we still have b cubed and c to the 4th. All right, so writing out your LCM, I start with the numbers first and then do the variables. So in my first term, I know I need all three of these numbers for sure. So I always rewrite all three of those. Okay? Or all the numbers that were in your first term. So 3 times 2 times 2. Moving down to that next one. Well, I already wrote down a 3, so I don't have to write down a 3. But I don't have a 5 written down here, so I need to include a 5. And then moving down to 8, I have a 2. I have a 2, but I don't have a third 2, so I need to include a third 2 here. Okay, next I can do the variables. So for the variables, I like to leave those squares and to the third or to the fourth there because you want to pick out the one with the highest exponent for your least common multiple. Okay, so it's always the one with the highest exponent. So for your a's, that would be a squared. Okay, so I can write a squared. For b, these both have 1, but this one has 3. So that would be b cubed. And then c would be c to the 4th, since that is your highest exponent for that one. Now all I have to do is multiply all of these numbers together. Okay, so you can use a calculator to do that. You should get 120. And then I have a squared, b cubed, and c to the 4th. And that would be your least common multiple. Questions on letter A. So that's one where we don't need to factor out a polynomial. Okay. In letter B, we do need to factor these polynomials. So we have 2 here. Okay, our first one is 4a squared minus 12a minus 16. Okay, so we want to factor this. Now the first thing I would do when you're factoring this is look to see if I can take out a term from all 3 of those. Okay, all 3 of those are divisible by 4, so I can take out a 4. Okay, what I have left then, I have an a squared minus 12 divided by 4 is 3a, and then minus 4. So if I were to distribute that 4 back in, I would end up with this again. So now I can factor this piece. Okay, so you can do the x method if you need to. What multiplies to negative 4 and adds to negative 3? Negative 4 and 1. Okay, so I still have this 4 out front. That's multiplied by a minus 4 and a plus 1. Okay, so that one's factored. So I want to do the same thing to that second polynomial. Okay, so we have a cubed minus 9a squared plus 20a. And again, we want to look to see if there's anything I can take out from all of those terms. And all 3 of those terms have an a, so I can factor out an a. Okay, then I have a squared minus 9a plus 20. And now I can factor that one. So again, I can do the x method here. What multiplies to 20 and adds to negative 9? Negative 5 and negative 4. Okay, so here I have a times a minus 5 times a minus 4. All right, so now I can start writing out that least common multiple. Okay, starting here, I need all of this right off the bat. Okay, so I have 4 times a minus 4 times a plus 1. Okay, looking at the next one. I didn't have an a by itself, so I will need to include that in my least common multiple. From here, I didn't have an a minus 5, so I need to include that as well. I did, however, already have an a minus 4, so I don't need to include another one. Okay, you can keep it like this if you want, but I like to put this a out front with that 4, so I'm just going to rewrite it as 4a, make sure I don't run off the page here, 4a times a minus 4 times a plus 1 times a minus 5. Okay, and that would be your least common multiple. Any questions on finding least common multiple? All right, so that's all right. I'm going to talk for a little bit here at the bottom. As with fractions, rational expressions must have common denominators in order to be added or subtracted. Okay, so when we're adding together fractions like you see up at the top of your page underneath where it says polynomials, you need to make sure those two denominators have the same numbers in them, okay, in order to add those numerators together. So to add rational expressions, you want to find the least common denominator and rewrite each expression with that least common denominator. So for all a over b and c over d, where b and d can't equal 0, it makes those undefined. Okay. If I have a over b plus c over d, I need a common denominator of their least common multiple. So since I have a b and a d, I would need to say my least common multiple or denominator is b times d for both. Now to get a d into this b, I need to multiply it to the top and the bottom. And for this b over here, I need to multiply top and bottom in order to combine it. Okay, same thing with subtracting. Okay, you need that least common denominator in order to subtract them. Are we good? Do we got all of it? All right, so on the back, we want to simplify 5a squared over 6b plus 9 over 14a squared b squared. Okay, so we're going to take our two denominators and do what we did on the front. Okay, so 6b, and we want to find its factors. So 6 is 2 times 3. And then I still have this times b. Okay, next I have to do it to the other denominator. So that is 14a squared b squared. Now 14 is 2 times 7. Okay, so we have 2 times 7, and then we still have a squared and b squared. So again, I want this least common multiple between both of them. So starting with those numbers, I'm just going to rewrite 2 and 3 because I for sure need those two. Going on to that second term, I already wrote down a 2, so I don't need another one, but I do need this 7. Okay, so multiply by 7, and then your variables, whichever ones have the highest exponents, that would be a squared and b squared. Okay, then I can multiply those 3 terms together there, which is 6 times 7, so 42. And I have a squared, b squared. Okay, so that's what your denominator has to equal. So to change your fraction now, I still have 5a squared over 6b. I need to change this 6b into 42a squared b squared. So I have to multiply the numerator and denominator by the same thing to do that. So I need a 7. I don't have an a squared in that denominator, right? So I need an a squared. I have 1b, so I need one more. And I have to do that to the numerator and the denominator. Okay. We're going to do the same thing with this second fraction here. So I have 9 over 14 a squared b squared. And we need to multiply to get this denominator equal to 42a squared b squared. Okay? So this 14, if I multiply it by 3, will give me 42. So I need to multiply by 3. Now I already have a squared and b squared, so I don't need to multiply by a or b. Okay, so I just need to multiply numerator and denominator by 3. Okay, so from here, I can just multiply. So I have 5 times 7. That's 35. I have a squared times a squared. That is a to the 4th. And then I still have this b. Okay, and that should be over our least common multiple of 42 a squared b squared. Okay, I'm adding. Same thing here, multiply straight across. I have 9 times 3 is 27. And again, you should have that least common denominator of 42 a squared b squared. So now that I have a common denominator, I can combine my numerators. So I have 35 a to the 4th b plus 27 over 42 a squared b squared. And that would be your answer. Questions on how I got any of those numbers? Or why I multiplied, or anything like that? Okay, so we're going to do the same process in example 3, except this time it has polynomials. Okay, so just like up here, we're going to find the least common multiple between our two denominators so we can get a common denominator. So our first one here is x squared minus x minus 6. And we want to factor that. Okay, if you need to do the x method, you do the x method. What multiplies to negative 6 and adds to negative 1. X minus 3, x plus 2. Okay, then we have our other denominator. That is 5x plus 10. And we want to factor that as well. Both of those terms include a 5, so we can factor out a 5. What we have left is x plus 2 then. Okay, so our least common multiple, we have this whole term here. So x minus 3 and x plus 2. Looking at our second term, I don't have a 5 with this, so I need to include that 5. But I do already have this x plus 2 here, so I don't need to include another one. So this would be our least common multiple. Okay? So going over back to our fraction, we have x minus 1 in the numerator. That's over. I'm going to keep this in factored form here. So I already factored this. It's off to the side here, so that's what I'm going to write in that denominator. Okay, so x minus 3 times x plus 2. Now to get my least common multiple for my least common denominator, all I have to do is add in this 5. Okay? That means I'm multiplying the numerator and denominator by 5. Okay, then we're subtracting. We have 4 over, again I factored that one already, so I'm going to write its factored form. 5 times x plus 2. To get that least common multiple, I'm missing this x minus 3, so I need to multiply the numerator and denominator by x minus 3. Okay, so now I can start multiplying across. So I have 5 times x minus 1. Okay, you need to distribute that 5 to both terms. Okay, so 5 times x and 5 times negative 1. So we have 5x minus 5 over, there should be a 5 out front here, 5 times x minus 3 times x plus 2. Subtracting, again, you need to distribute that number, so 4 times x and 4 times negative 3. So we have 4x minus 12. I'm going to put parentheses around that, and you'll see why. And then that again is over that 5 times x minus 3 times x plus 2. Okay, so now that I have a common denominator, I can combine my numerators. Okay, so here I have 5x minus 5, and I'm going to subtract this quantity of 4x minus 12. When you're subtracting, you need to distribute that subtraction to all of your terms in that numerator. Okay, that's why I added those parentheses, so you don't forget you need to distribute this. Okay, that will all be over this 5 times x minus 3 times x plus 2. Okay, so now I can distribute that negative. Okay, I'm going to start over here. So I'm moving. Run out of room. So I have 5x minus 5 minus 4x plus 12. Okay, so I distributed that negative. So now I have positive 12 here. Okay, that's over my common denominator of 5 times x minus 3 times x plus 2. Now I can combine like terms in that numerator. So I have 5x minus 4x. Okay, that's just x. And I have negative 5 plus 12. That's plus 7. And this is all over that common denominator of 5 times x minus 3 times x plus 2. And that would be your answer. Questions on example 3? Okay, so example 4 is a little bit different. You have fractions within a fraction, just like we were dealing with the other day. Okay, so the first step with these ones is to do what we were kind of doing up here. You want a common denominator within your numerator and a common denominator within your denominator. Okay? So separate these into 2 separate problems where you're finding that common denominator. So with this top piece, I only have one value. Okay? With that denominator, it's x, right? So to change this 1 so it has a common denominator, I'm going to multiply it by x over x. Okay, since that is my common denominator. That's the only term in that denominator. And then I can just keep this as y over x. This is subtraction. Okay, so that's the numerator piece. So I still have this fraction bar here. Now I have in my denominators of these two a y and an x. So my common denominator for those ones would be xy, right? Okay, so to get this y to be xy, I need to multiply the numerator and denominator both by x. Okay, so I'm going to take 1 over y. We have to multiply it by x over x. Then I have addition, and I still have this 1 over x. Now I'm missing a y in that one, so I want to multiply the numerator and denominator both by y. Okay, so now up here, I have 1 times x over x, which is just x over x. And I have y, minus y over x. In that denominator piece, here, multiply straight across. So I have x over yx plus, again, multiply straight across. I have 1 times y is y over, just going to write it as yx because that's what I did in the first one. Okay, so now that I have a common denominator for this part and a common denominator for this part, I can combine those. So I have x minus y over x. Okay, so that's where I'm getting this one from. That's over. I can add together x and y here. And that's over xy or yx. Okay, so now remember when we had that larger fraction bar there? That was your divided by symbol. Okay, so this is like saying x minus y over x is divided by x plus y over xy. Now when I have it to this part here, what do I have to do? If I'm dividing by a fraction, multiply by the reciprocal. Good. So I still have x minus y over x, and I'm going to multiply and switch your numerator and denominator. Okay, so I have xy on top and x plus y in the denominator. Okay, if you want, you can put parentheses around these ones, okay, since we're multiplying. So I'll end up with x times y times x minus y over x times x plus y. Do I have like terms that I can cancel?
Sure.
Yeah, I do. I have x over x right here.
Yes. That's what I'm saying.
Okay, so those x's will cancel. So we have y times x minus y over x plus y. Questions on how I did that one? It's just taking it one step at a time for problems like this. Okay? So you just need to find common denominator for this numerator part. So if you need to cover it up and find that common denominator. Okay? Same thing with that larger denominator there. Cover it up, find your common denominator, and combine those. Okay? Don't look at it as a full problem right away, so that you can eventually get to this point and then change it to multiplication.